Awesome. So this is question 3.5 and it's called sort stack. Now for this question, what we're going to do is we're going to write a program to sort a stack so that the smallest items are on the top. Now we are allowed to use a additional temporary stack, but we can't copy these elements into any other data structures like an array or say a linked list. And we just want our stack to support all the basic operations like push, pop, peek, and isEmpty. So often when they define constraints, it's actually kind of a hint here where you should just use a temporary stack and you won't need the use of an array or a linked list. And so what we're going to do is I just instantiated this stack here, simply called stack, and I just pushed 5 arbitrary integers to it. And I've defined a method here called sort stack, and it's just void since we're going to be doing this in place. And we're just passing our stack as a parameter. And then finally, we're just going to iterate through our stack and then popping off the elements from it and just printing out to the command line just for debugging and checking our answers. So now before we actually go through this algorithm, I'm going to show you on the whiteboard what we're going to implement and just kind of illustrate how it actually works visually, and then we'll actually go through the implementation itself. So here is the exact same kind of order that we push to our stack in our driver program. And what we're going to do is we're simply just popping these elements from our stack, storing them into a temporary variable. This is just an integer. And then we're going to push them to our additional temporary stack that we're allowed to use. And it's just called util stack. It's a utility stack. Now we're going to continue to keep popping these off and pushing them to this util stack until we hit a special case, and I'll describe that in a second. So we'll take 2, which is at the top of our stack, store it in a temporary array, then we're going to push it to our utility stack. And so next, what we're going to do is, now that this util stack is no longer empty, we have this greater than symbol, and we're only going to push to our stack when what's stored in our temporary variable, the value that we just popped off of this array, is greater than the top of our utility stack, okay? And so 7 in this case is greater than the top of our utility stack. So we're going to push it to it. But now when we pop 3 off our stack and store it in this temporary variable, we see that 3 isn't greater than the top of our stack. And so what we're actually going to do is we're going to pop the top of our utility stack and then just push it into the original. And then we're just taking our temporary integer here and then storing it or pushing it to our utility stack, right? And so what we're trying to do is actually store all of our values in increasing order into our utility stack, where the minimum is on the bottom and the max is on the top. And so in the question itself, it wants us to have our stack sorted so that the smallest elements are on the top. And so to get this, what we're going to do is, if we store it, in increasing order in our utility stack, all we have to do is, when this is full with all our items, we can just pop them off one at a time and push them to the stack. And then we're actually going to get it into, decreasing order as you pop them off. Okay? And so we're going to illustrate that. I'm just going to go through the entire stack using this algorithm. And so next we have 7. We pop it off, store in our temporary variable, and it is greater than the top of our utility stack, so I'm going to push it. Now with 5, we see that 5 isn't greater than the top of our stack, so we pop 7 off and push it into the original stack. And now we just push 5 into the utility stack. Now with 7, this is in fact greater than the top of our utility stack, so we can push it to the top. And now you can see 1 here is not greater than the top of our stack, so we're going to store it into the original. Same with 5. 5 is greater than 1, so we're going to store it into the stack. Same with 3, and then same with 2. And so we push 1 to our utility stack. We're just going to go through the same algorithm, but since these are all, in increasing order, as we pop them off, they can easily just, be pushed to our utility stack. So 3 is greater than 2, 5 is greater than 3, and then 7 is greater than 5. Okay? And so now that this stack is completely empty and this utility stack is completely full, we can start just going through this utility stack and popping them off and then pushing them into our original stack. So 7, then 5, 3, 2, and 1. And just like that, we now have a sorted stack and where our smallest items are on the top. So it's just, it's in, I'll call it increasing order, or, in decreasing order as you pop them off. So I guess in decreasing order. And so that's how our algorithm works. So I hope that makes sense. It might take a minute to digest, but maybe the implementation will, help you grasp it. So we're going to do that now. So the first thing we want to do is just instantiate our utility stack. So it's going to be a stack of integers since we're, dealing with these values here. And I'll call it util stack. Great. And so we're going to iterate through our stack until it is empty. And this is the original stack that's being passed in the parameter here. And so now what we're going to do is we're going to pop the top of the stack off, and we're storing it in this temporary variable that we're using, right? So I'll just kind of put this back in the original order. So 1 was down here. Oh. To move this. 5 was here. 2, 7 was actually down here. So, we pop 2 off and store it into our temporary variable like this. Stack, we pop it, we store it in our temporary variable. And so, after this special case condition, what we're going to do is we're just, pushing this temporary variable into our utility stack. So we're just going to leave the special case blank for now. So case, and then we would be pushing this temporary variable into this utility stack. Right? And so now to go into the special case, what this will do is our condition will be, okay, we want to take whatever is in here. So one case was when we were at 2, 7, and then we had 3 in our temporary variable. We want to actually take the top of our utility stack and push it into the original when 7 was greater than our temporary variable, okay? And we want to keep doing this until our temporary variable is greater than the top of this utility stack. And so we want to do this while, because we're going to be continuously popping them off. We only want to do this if the utility stack is not empty, because we don't want to pop anything off the utility stack if it's empty. So util stack, while util stack is not empty, and our temporary variable is less than the top of our utility stack. So if our utility stack's top value is greater than our temporary variable, that won't be in the increasing order here, so we'll want to pop it off and just temporarily store it in our original stack. So like this, so we just take our stack and we push the top of our utility stack. Great, and so with this algorithm, we're going to have it all stored in here. So that's in increasing order, so that would look like this. And with this, now all we're going to do is we're going to take these variables off. We're just going to iteratively be pushing them or popping them off our utility stack and pushing them so that it's stored in decreasing order into our original stack like this. So while our utility stack is not empty, because we don't want to pop anything off if it's empty, because then we'll get an error. We're just pushing to our original stack the top of our utility stack. We're just popping that top off. Great, so why don't we go ahead and run this program. Oh, we just have a quick error right here. Great, and so now you can see we have that sorted order. So if we had it here, it would be 1, 2, 3, 5, and 7. And so this is the top of our stack, so we would pop this off first, 1, and then print it like we did here, and then 2, 3, 5, and so forth. So that's what we did, is we just took the top of our stack, popped them off, and we're printing them, iteratively here. So yeah, I hope that helped. And I find a lot of these questions just, with stacks and queues, we're either, making use of an array, making use of 2 queues to you make a stack, or, it's generally always questions to use, another stack or 2 queues or 2 stacks to implement a queue. So it's very good to always kind of think of these problems, in terms of, okay, maybe I could use, a queue in this question, or a stack for all these kind of array, stack, and queue questions. So it's a great problem, and I definitely recommend going through this and whiteboarding it so you can kind of understand what's going on. So it took me a couple minutes to figure it out. So yeah, I hope this helped, and good luck with the rest of your algorithms. Thank you.